Hello and welcome to day 14 of Advent of Code. Again, we are trying to solve both puzzles using Kotlin, and yeah, let's start. Day 14, extended polymerization. The incredible pressures at this depth are starting to put a stain on your submarine. The submarine has polymerization equipment that would produce suitable materials to reinforce the submarine, and the nearby volcanically active caves should even have the necessary input elements in sufficient quantities. The submarine manual contains instructions for finding the optimal polymer formula. Specifically, it offers a polymer template and a list of pair insertion rules. Your puzzle input. You need to work out what polymer would result after repeating the pair insertion process a few times. For example, NNCB. The first line is the polymer template. This is the starting point of the process. The following section defines the pair insertion rules. A rule like AB to C means that when elements A and B are immediately adjacent, element C should be inserted between them. Okay, between them. These insertions all happen simultaneously. So starting with the polymer template NNCB, the first step simultaneously considers all three pairs. The first pair NN and NC, CB, and that's it. Let's see, NN is then NC and then CB, okay. The first pair NN matches the rule NN to C from this list, okay. So element C is inserted between the first N and the second N. The second pair NC matches the rule NC to B, so element B is inserted between the N and the C. The third pair CB matches the rule CB to H, so element H is inserted between C and B. Okay, that is okay, yeah. Note that these pairs overlap. The second element of one pair is the first element of the next pair. Also, because all pairs are considered simultaneously, inserted elements are not considered to be part of a pair until the next step. Okay. After the first step of this process, the polymer becomes NCNBCHB. Here are the results of a few steps. Okay, we do this multiple times, I see. This polymer grows quickly. After step 5, it has a length of 97. After step 10, it has a length of 3073, and so on, and so on, and so on. Taking the quantity of the most common element, B, and subtracting the quantity of the least common element produces 1588. Apply 10 steps of pair insertions to the polymer template and find the most and least common elements in the result. What do you get if you take the quantity of the most common element and subtract the quantity of the least common element? Okay, that seems straightforward. There may be some tricky parts because we first need to find all the insertions and then apply them afterwards to not get confused with our pairs. Or we create a copy and insert into the copy. Well, let's see. Like always, let's switch to IntelliJ. Well, let's get the puzzle input first. That's a big one compared to the example. Okay, here's IntelliJ. Let's create a package for day 14. And then we need the input again. Here it is. We name it day 14. And yeah, let's start with reading the input again, I guess. And like we did the last 2 or 3 days, I think we will again make a lot of use of testing, because that actually worked really well, like the examples that are given here. If we put them into tests, then it should be really easy to get to the solution. But let's write a template. We usually have a part 1 and a part 2 function, and then a main function. Can't type. From which we will execute part 1 at some point. And then let's go to the test. Create a test. All right. And then let's start with reading the input, and I think we'll do the same we did the last times, and that is we have a read file function and something like read from string that we will make use of in tests, and read file will essentially use the read from string function. So we need a file name, we throw this into the file class, then we read all text from it and throw that into read from string. And this is to do. So we need to figure out how do we want to represent the data. We need a template and a mapping. So I guess, yeah, that will be just a string and a map. Do we want fancy types for that, data classes or whatever that wrap those? I don't see the need for that just yet. So I think we will say read from string will return a pair, which is the template, a string, and then a map of strings to other strings. Could be a character, but I don't see like a big advantage of using character here. And then we say return here and give this the same type. And then I guess we can start writing our first test, and that is just testing read from string. And if we throw in this input here, whoa, wait a second, this is formatted wrong. This, and then we want a template and a map out of read from string input, and the template should be this template, and the map should have 16 entries, I think. 16, and that is map size. And then at some point we will also check some of them. Let's say age. If we say map of BH, then we want age, and something else, maybe the last one, we want to see if we get CN. Right, let's put a test annotation on that, and let's run this. Build. Okay, not implemented. That is exactly what it should look like, because it just says to do. Okay, I guess what we can do is split this into lines, and then our template will just be the first line, and then we lines drop 2. We essentially ignore the template and the first empty line, and then we just pass those lines for line in, lines drop. Yeah, okay, that is fine. Let's create a map, mutable map of string to string. And if you have a line, then this is from two line split. We split the line exactly here. And then we say map from equals to. Then we return a pair containing template and the map. Let's run our test. Awesome. It never worked that fast. All right, what do we need? We need the template. And we need the map. And then we need to perform the insertion. Let's say perform insertion. We have a template that is a string. And then we need this map that we talked about, which is a map of string to string. And we return the new string. So write a test for that. Test perform insertion. We steal this. And we steal this. And then we say new template is perform insertion template and map. And then we expect this to be this or this. All right. Won't work. Obviously, a return expression. Okay, yeah. Say to do. Let's just run it to make sure it's doing something. Awesome. Now let's implement this. How do we want to do this? Essentially, we need the pairs first. For every pair, we can remember at what position we want to insert something. And then we perform the insertions with the drawback that once we insert something, the following insertion positions will move, obviously, but if we loop over them with an index, then I guess they will always move by the index. So maybe that will be nice to do. We will be creating a bunch of strings. Maybe we can be smarter and use a builder. Yeah. Maybe we can. How? I don't know. No, we will figure that out. Let's see. Let's first find the groups. And recently I came across a windowed, which is, I think, exactly what we want. We want a window of 2. We want step size 1 and partial windows. Actually, maybe write this out. And we do not want any partial windows. And then we go over each group. And let's just print those groups for now. Just want to see them quickly. NN and CCB. NN and CCB. Yeah, that is correct. Okay. So now we have the groups. Now we need to look up. Is there something like window? Well, maybe we do not need those. Window. I was wondering, is there one that gives us also the index so that we know where to insert, but I guess we can just fill up a list. So let's say insertions are a mutable list of strings. And then we say insertions add. Now we just look up map of group. Which can be null. If it is null, well, let's move this out. Insertion equals this. If it's null, throw illegal state exception. No mapping for group. Because it looks like we always should have one. Do we want to print those maybe? I wonder if we should test just this part, move it out into its own function and test it. But maybe we will skip that. We will add a C, a B, and an H. A C, a B, and an H. Yeah. Okay, now we only need to put this thing back together. Which essentially is, we take... It is this, right? We take one from the template. Template, 0. Then we take insertion, 0. Then we take template 1. Then we take insertion 1, and so on. Is this right? I think it is. So let's say string builder, build string. Now we loop over the template. Yeah, I think so, right? CBH. This is CBH. It's always in between. And it's the insertions are always one smaller. We need to make sure that we do not add one at the end, I guess. So template for each indexed. Or maybe we go over the insertions again, the index of the insertions, because that's small, and then we just add the last one. Because if we make this as a minimal example as possible, it will look like this. The last one, template 2, there will be no insertion here. So that means we could loop over the insertions, then just add the last character again. Let's try this. Insertions for each indexed, index insertion. Then we append template at the index and append insertion, and then at the end we append template last character. Let's run this. Wow, that worked. That was kind of a quick one, I guess. Now we need all the characters. That's another function we need. But before we do this, let's run this multiple times, I guess. Let's continue, I guess. Second template perform insertion on new template with the map. And then we expect to get this for second template. Let's run this. Third template, perform insertion at the second template with the map. Let's just make sure we actually get the right thing. This is the third template, and then the fourth template is this. No, stop. We take the third. Oh, sorry. We take the third template with the map and say this should be now this fourth template. Let's run this. Oh, it passes. Okay, now we need the quantities. Do we only want the highs and lows immediately, or all quantities, and then pick from all quantities? Count quantities for an input. And it gives us a map of a string to an int. Or does it? Yeah, I think so. And then we create helpers for max and min, I guess. So this one just goes over the characters. Or can we just count into a map? How can we count this smarter? This is just it just counts. We need to group it somehow. Group by. Maybe it's just group. Group by it, and then map to character. What does group by give us? Group by returns. Come on. Why is this so slow? Why is there no doc? God damn it. Group by groups element of the original array by the key returned by the given. Then we get a map to a list, and the key is what we return. Yeah, and can we, what do we get if we count this? Just get an int. No, we need to map the values. And that is a list, and we just want the size. Another list. Okay, we get the whole entry, so we say it is character we do not care about in the list, and we say we just want the list size, and then that is what we want. But apparently it's not, because there's a character. Do we care about that? No. Okay, I can live with that. And then let's say if we have that, we want the max and we want the min, which will be min by or null. Return min by or null. What does this return? Oh my god. It returns, oops, returns something awkward. A map entry. Okay, so this means if we get char character, wait, this is an entry, right? Yeah, it's a character. Well, wait, we do we care about the character? Yeah, I guess we do. Character and an int, or do we? We do not really, but we still will take it, I guess, since we have it here. We have a character and a count, and we want the min count, and then this returns our map entry, but we want a pair, I guess, to pair, and it can be null, but I think we never actually expect it to be null. We do not need the character after all, and this is a max by or null. And then it returns this as well. And now test find min max. Let's see, what kind of values do we have? After step 5, it has a length of 97. Let's try that. And let's create a var this time, and then say repeat 5 times template equals perform insertion into the template with the map, then assert equals length is 97. After step 10b occurs. Oh, okay. Let's run the 10 steps then, I guess. After 10 steps, we have a length of 3000 template length. Let's see if this is true. Yeah, that is true. Min character min value is template. What was the thing we wrote? Count quantities. Count quantities. Does this return? Oh, this is just our map, right? Okay. Quantities. How many entries should there be? There's only N, C, B, and A. N, C, B, and H, right? N, C, B, and H. It should be 4, right? Test this. Yep, that is true. And now min value and the min character equals quantities min. Now let's do this for max as well. Max, max, max. Let's print this. Min value, and then for max the same. Max character, max value. Let's run this. H and B. Yeah, let's also turn this into an actual test. We want to have an H as min character. We want to have 161 as min value. Let's copy this. Max character, max value, and that should be B and this. Let's run this as a test. Whoops. What went wrong? Oh, this is not a string, this is a character. Okay, we can live with that. All right, passing. So now we can actually run implement part 1. So read from read file, and the file name is day14.txt. yeah, and we expect to get a template and a map. And now apply 10 steps, repeat 10 times. Let's make this a var. Template equals perform insertion template map, and then quantity of the most common and subtract the quantity of the least common. Let's steal this piece of code from our test to determine the quantities, and then we want to say the result is max minus max value minus min value, and then let's print this. Let's actually run it as well. Index out of bounds. Interesting. That is something we didn't have before. We split. Oh, this is the empty line at the end, right? Yeah. This time actually let's handle it. Is there something drop last one? What the hell? Assertion error. Why is that? Oh, we copied the assertion. Oopsie. $2,988. Put this in. Right answer. Awesome. Let's see what part 2 has for us. The resulting polymer isn't nearly strong enough to reinforce the submarine. You need to run more steps of the per insertion process. A total of 40 steps should do it. In the above example, the most common element is B, occurring a lot of times, and the least common element is H, occurring a lot of times too. Subtracting these produces a huge number. Apply 40 steps. Okay, so step 1, we copy this and run it 40 times, and I feel like ints won't do it, but I'm just curious whether it will just do anything at all in a reasonable time. Okay, it is running and doing a lot of things. Yeah, we are building very large strings. If you let's stop this for a second. If we imagine in the example above, B is occurring that often, and element H is occurring that often, then this is a lot of stuff. So we might need to be smarter than actually constructing the string. Maybe. So the question is, can we find a way to know the groups and know the number of insertions without creating super long strings? How can we do this? Let's even can we even run the example 40 times? Was this already too heavy? I almost assume it is. No mapping for CN? What the hell is suddenly happening? Oh, yeah, that is a problem. Let's do this. Let's solve this differently. We trim here and stop doing dropping the last line. That is not what we want. Okay, let's run this. Okay, let's try running this 40 times. Okay, let's stop this. This is not going anywhere. We need a... Let's really stop this. Kill it. We need a smarter way. So count smartly. Let's say we have a template and we have a map. And let's try to be smart. So we have this, and we have NC, oh, sorry, NN is C, and we know NC is NC is hello B, and we know CB is H. And that is the order in which we look at things. And we know if we get an NN, we insert an NC, and we know it is NCN afterwards. And we know this means there will be new groups NC and CN. So, can we somehow count the characters without building the string? Because we know there will be one more character. This is the C. How can we do this? Let's imagine we do only one insertion. Then on every insertion we can ignore this part and add the count for those. I guess for every position we could try to do all the insertions already, because they are limited to this position, right? If we let's keep this for a second. If we go through the windows, the new groups are limited to that. So we do not need to build the whole string. We only need to do it 40 times for NN. Count them. And then move on, because let's look at this here. And the things we've built. The original string was NNCB. Let's copy those over. And then let's also look at this at some point. So we have NN. This one comes from N. And then we have NC. This one comes from NC. And the H comes from CB. Now here we have NC adding the B, and CN is adding, what is CN adding? Let's quickly steal this. CN is adding C. This is this, let's go back, the B. So we added the C. The CN added the B. This is the C from above. And then we have okay, I'm confused again. Let's go back. Let's only look at one item, one group, NN. NN added NCN, and then we had NC, which added the B, and then we have this here, and then we have CN, which added the C, which is this one. And then this is all the old crap. This is all coming from the first group down, cascading down. And we do not care about whatever comes next. It's still the NN, which is just getting bigger. So we could maybe try recursively do this just for one group. So if we keep that and we do not do this, or maybe we keep the insertion. We have the first group and we have the insertion. And now we need to go down until we have done this a bunch of times. So let's say we do this n times. And if times 0, then we have done this n times. Then we return what do we actually want to return? The quantities maybe? Let's try. Then we just count the quantities in this one single thing, which might still be very large, to be honest. I guess we could try. How about we try this? Let's comment that out for a sec. What if we take this maybe just now I have a new idea. Minimal or let's say small. Let's take this as an example. But let's rewrite the template and say the template is just NN. Stop. Well, it will try multiple things. Let's say the template is just NN. And now we repeat 10 times the thing just with NN. Equals template. Now perform insertion into the template and then map. And then just print the quantities. Let's do this 10 times for test. This is a to-do. And we wrote broken code. Yeah. Curly brace. Bracket. X out of bounds. What did we break? Where's this? Oh, trim ident. Okay, let's say we want to do this 40 times. Can we do this just for an NN 40 times? Not really. The idea was, let's not build a huge string. Well, let's kill this again. The thing is, we still do not need the huge string. We only need to do this recursively for the groups and then get them back together. Count. Let's say we get a group, which is a string, just 2 characters. And then we say times. And we say we return our count-ish. We say if times is 0, then we are done. So we return the quantities of our group. Otherwise, we say return count quantities of no. This is our count function. Count the group of first count. We need the insertion. Oh, yeah, we also need the map. And then we merge the counts. And we say, hey, instead give us the count of the group plus the insertion with this map and times -1. And the second count is the insertion plus group 1. The problem is we do not build the string, but in the stack trace we will have the string anyways, just for the first position, but this did never complete the insertion for just an n. But we had to build the string all the time. At least we are preventing that. Now we need a way to merge them. Merge with map. And then we do, what do? We need to merge the keys first. Keys plus map keys, and then make them distinct. And then we go over them. Or maybe we map. Well, we need a new map. Counts is a map of character to int. I don't think this will be performant enough, to be honest. I still want to try it, because I expect this to have such a big stack trace that we might not be able to actually do it. But we go down the first group that gets bigger, and then we return it back up, and maybe it does. And then we say counts for this character is get or default for character plus same for the map. And then here we return first count merge with second count. And this returns a new map. And let's write a test for this. If we say this is the template, and we can still do this for 10 because we have the numbers here. Oh no, we only need this for n. Count. Our group is just a template. Oh, actually, let's say nn here. We do not need to change the template. We have this map and we want to do this 10 times. What are our counts? Let's do this. Okay, let's print them as well. All right, those are our counts. Let's do this 40 times. Doop, 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 doop. Now, same problem. Now we do not build a string, but we build an equally complicated recursive stack trace. And this is only for an n, and if you look at the actual input, wow, that is a huge template. Running this 40 times, that will be massive. So we kind of need a way to count those groups without building the string. And I still think we can do this. We just need to go through those windows and somehow end up counting all the insertions we do. Okay, new approach. 1 hour in, let's see. Not good. Let's find a new way. Count smartly. It's still the function that we haven't implemented yet that will do it. Let's go back here. If we see an n, we can immediately say count the n. The n doesn't matter anymore. Count the n. And the NC, something we need to look at, but we do not need to count it. We could already count the C. In theory, we could. But then we will go down and have the B. We only need to keep track of the count of the things in the template and the thing we would insert. But those create new groups that we need to look at. It is almost this. It's again this what I want to write in my head. Let's make a quick check. If I run this 20 times, is this already too slow? 20 times works. 30 times. Is where it's slowly falling apart. What is the problem here? The problem here is that we still build up the stack trace. We want to avoid going deep in the stack, and we want to avoid building all this super long string. Let's go back to the example again. CB doesn't matter. If we see group NN, and we can count. Hey, we have N2. And then we have NCN. Now we already counted the N. And even if we want to count the C, it would be in two groups. So we would need to make sure we only counted once. Ideally, we just go through the string and do all the counts in one go. Do we even need to do the replacements to figure out what the count is? We see NN, we know, hey, the replacement is a C, so can count that. The problem is that we will have new groups. We also need to merge them. Like, could we just optimize this away? Actually use mutable things. Let's not return a count, but make it a mutable count and then pass the actual thing around. Is this cheaper? Problem is, if we look at this is so huge. This is so huge that we cannot really do this. With a string or a stack trace. Hey, there was a cut here because I was trying a bunch of stuff. I tried to implement a clever way to count, which is not clever at all, where I was still trying to go down the stack trace. That didn't work at all. Then I wanted to be even more clever with the queue, which has the same problems. And count smartly, that's the one where I only took notes, which I never implemented. And the same problem kept happening, where essentially it's running for too long. Or we are building huge strings, and yeah, it is not solvable this way. So what I did is I printed this out actually on paper. And I stared at it, and now I have an idea, and I will try to implement that. Maybe that works. Essentially, I was starting by looking at, is there any rule by which we can know which characters will appear so that we can kind of calculate the count without actually building the string? But all the time I was thinking, whenever we do this, we end up again going down a stack, and that is not helpful at all. So then I stared at this list, and then I had a great idea, which I think will lead us to the solution, hopefully. And that is, with those mappings, we know that the number of groups is limited. So whatever we do, we will only see those groups whenever we look at stuff. That means that since the order is not important, that was another key moment I guess I had. Like, that this is NB here and BB is here, no one cares. We only care about there's one NB. And there is one BB and so on. And that led me to the idea, maybe instead of having this, we want, oh, this is another help I wrote. This merger was another count. So I had the following idea. Instead of knowing this means inserting B, how about we expand this, and now we will have those. We will have to keep track of those groups. That means we only need to count them. Let's say we see a CH. We know this will be a CB and a BH now. So we could just keep track of the groups. So we will, whenever we see a CH, we will keep track of those. Or let's say we only need to expand CH, just to make it simpler. We have one CH. We go through this list that we expanded. We know now we need our new counters, one CB, one BH. Now we repeat this process, we go through this, we count new counts and so on. Let's say at some point it looks like this. And then we only need to count, but we need to count the individual pieces. Now we have counts of groups. But we do not need the groups, we need the individual characters. We can't reverse them, but we can track them separately, I guess. Let's say we again start with ch. We now know two things. We have this map, but we also have this map. So we can process to say, hey, you see in ch, we count a b, and we say we have one cb and one bh. And then we go through this list again. Now, I think the great thing here is here we only count the insertions, and here we keep track of groups. At the end we have a list of insertions, and the only thing we need to add to those is plus the characters of the template, because those we never inserted in the first place, so we need to count them too. And I think what will make this faster is we do not need to look at all the groups, which will be a ton. At some point we will have this, and that means we look up cb, which will be an h, and then we know, hey, h will be h plus this huge number, and then we have dealt with all of those groups in one go. That is, I think, is the key. Now we just need to implement this. So what do we need? We need a function count all the things. We will hopefully come up with a better name. And then we need a character map that will map a group to a character char. This is this map. And then we will also have an maybe expand map, because we kind of expand, or insertion map, which is mapping a string to a pair, which essentially needs to do this lookup. And then we also need a count, which we might not need here, but we need it here somewhere. Count, that will be also a mutable map, I guess, from a character to a long, because those numbers are huge and not even sure if a long will be enough, to be honest. That is super long. Super long. But we can still switch to something else later on if we need to. Mutable map. Then I guess we just return this. Then we can find the min and max. That is the easy part, I guess. So let's say we have a character and a long map. So now let's implement exactly this. For every step we need to first get all the counts, the groups, so we need to this map where we count the groups, count characters, I guess, and count groups. And I guess we need to insert the first round of groups or a template. Maybe take in the template. This is the initial one. We know that we can get the groups like this. So create groups, create group count, which will be map from a string to a long. And it needs a template string. And this is kind of this here already. Oh. So we have those windows, which is a list right now. And then we use those as keys, I guess. How do we create, what's the easiest way to create a map from that? No, I want to map it to a value, or maybe we could actually. We map it to a pair of group to group to a pair of group and 0, and then we create a map from that, and we can return this. And this should be a long. And how can this be simplified? Associate with. Okay. Let's create a test for that, because I'm not sure if this is working. This can go away. What was the name? Test group count. Let's say we throw in this template. Then we expect the following map. NN0 and C0 and CB0. 2, 2, 2. And those are longs. That is what we expect to come out of this function. Let's test this. Okay, there's still something. Oh yeah, this one is actually not really implemented yet. So to do. Okay, does what we think it should do. Group count. And maybe this is var. Where is it? Do we need a mutable web? Let's figure it out later. Okay, so we have a map that maps characters to counts, and we have something that maps groups to counts. What is the algorithm we want to build again? We might also need to keep track how often we want to do this, I guess. Maybe let's do it just once for now, and then we add the loop later on. If we have our groups, then we go over the keys in our group. We actually need to count, so let's go over all of them. Group count for each. For each of them, we will what will we do? We have a character. No, stop. A group and a count. And then we will look up what do we insert. So in the character map, we look up the group. This is the insertion we need to do. If we do this insertion, how did I think we do this? Oh yeah, we just count all the insertions. That is fine. That is still good. So count characters, and now let's write this helper. If we have a map of chars of longs and we want to add a character, then we look this up or use 0, and then we init put now I'm confused. Why is this not add? Am I completely confused? Oh, it's not a mutable map. My God. Let's get the value back, and then we put value +1. This means in our let's also let's call this count, maybe count the insertion. Oh yeah, if this does not exist, then we throw unknown group, or let's say no mapping for group, no mapping for group. And then we need to find the new groups. Group, let's first group will be first character of group plus the insertion. This is a string, maybe a char. Char plus a char is not a string. Let's create one. Group 0 and the insertion, and the second group is the insertion and 1. Now the question is, do we still need to keep track of the count of the previous groups? I don't think we do, right? We only need to make sure that here we actually count this so many times as we have those groups. So count can be a long and then we need to remember the new groups. Updated group count. It's a mutable map of, yeah, we need a separate map because we do not want to we definitely do not want to, while we go through all the groups, we cannot change the number of groups because that would be confusing. Like the exercise says, first we do all the insertions, then we do the next step. Or first we determine all of the groups and then we insert them. That's how we implemented it. So the updated group count is still the same. No, not this one. It is string too long. And then we also need to kind of mutable map string too long. A count here. That is the group and the count. Make sure this is a long. We look up the group and we put group, and this is value plus count. Oh, and this one we actually do not. That was bullshit. We do not need to build this ourselves. We can look those up in the insertion map. First and second. Actually, well, first and second equals insertion map get group. That's how we will look up which kind of group we need to deal with. Illegal state exception, no group mapping for group, no character mapping for group, no group mapping for group. And then we updated group count. Now we only need to keep track of the new groups, right? Let's say we had a B in ZC, then we only need to keep track of those groups now. Not AB anymore, yeah? That is correct. Updated group count. Count first and second. No, count first and count second. In this one case, I guess it's always just adding 1. And if we do this once, we will end up with what? Guess now we can just return the character with 1 extra, and that is we did not add the strings from the very first group. Just a template char array for each count characters count because we only added counted the insertions, but we did not count this one. Okay, this is now a different count function. That is not good. Definitely not. This is our count, right? Yeah. And this is only one turn, and we would need to do this multiple times. But let's try with 1 time and see if this works. Test count all the things. What do we want to do? We actually need those maps, because this one now fortunately returns a map of string to string. Maybe we want to have a char here. Can we change this quickly, or should I write a new version of this? Read from string. Okay, well, let's test. We need a template. Let's say we take this here. Count all the things. count, or actually count map. This needs a template, we already have this. Then we need a character map, which is almost this map. We just need to turn it into one. I guess we can just do it here. Not nice. A character map, that will be our map. Map 2. Oh god. Actually, we want to map the values of group to character, and now we want character 0, and we do not care about this. And we insert this here. That's our character map. And now the insertion map, we might want to write a helper for that, maybe. So we have this character map, and with that we can turn it into the insertion map. If we have a map of a group to a character to how did we call this? Insertion map, right? To insertion map, which is, so it's getting really confusing to read and talk about it. But the insertion map maps a group to a pair of a group. We do this by mapping the values, which is again a group and a character, to a pair of group group 0, group 0 and the character, and then the character and group 1. There is definitely something wrong here. This should be like this, which is a char. See, that's this. No one complains. Let's write a test for this. Do we still have this one? Yeah. Fun test. Insertion map creation. And we have a map that maps currently strings to characters. Let's steal those. Only take the first 3 for our test. Two and 2 and done, and then we say insertion map equals map to insertion map. And then what we want out of this is a map that looks like this. list of CB, HB, HN, NH, CH, and BH, no, HB. Let's run this. Okay, this did not work intended, which did I do something wrong? If you insert a B, yeah, this should be H. If you add an N, if you add an H, how about this? Still a difference. Where is it? It looks right. Oh, it is not a list, it's a pair. Let's run it again. Awesome, so this is working. Back to count all the things. We need an insertion map. And we can do this now. We have a character map and can turn it into an insertion map. Now we want to count all the things. Insertion map, and now we print a count. Or count map. See if this runs. I want to run all of them. Stop. Find min max. Oh, this is still the test that runs it 40 times. That is not what we want. Right. But this still looks like the result for 10 rounds. Let's see. Didn't want to destroy this test actually. I think with 10 it should still pass, right? Yeah, okay. And let's go back to count all the things. It just does this one time. It again runs all the things. Oh, this is not annotated. Okay. Now just run this one. Is this correct? After step 1. After what is the template again? The template is NNCB. So the count should actually look like this. This looks like the original count. Do we return the wrong thing? Updated group count and count characters. Yeah, why did count characters not do anything at all? Let's see if we do not do this at all at the end. Then it's just empty. How did we even end up with empty? Count characters, let's debug this quickly. Counting character value plus count. Okay, we are always counting 0. That is obviously wrong. Why are we counting 0? Because this group is only existing 0 times. That is wrong.
You are 100% wrong.
Oh yeah, we might be initializing. We might be initializing wrong. Is this the thing we do? Where's our test for this? Oh yeah. We create a group count for this template, but all those groups should exist once. 0 is wrong. Run this group count thing again. Okay, now it's 1. Now back to this one here. Count all the things. Let's run this. Now it's 1 everywhere. And now we need to add in the count for those again. And now it's this. Let's go back to the example. After step 5, we should have those numbers. Let's try that. If we now add a counter, so we want to do this n times, which means we need to update groups. So group count is probably needs to be a var. Then we say times, oh no, repeat times. Now we do this multiple times. And after every round, we update group count to the updated group count. And now let's say we want to run this 5 times. This should give us, oh wow, an error. We seem to be modifying the list we are looping over, which, why can I not switch to this line? 290, which is not actually the line. So this is the updated group count. Oh, and then updated group count needs to be an empty list again. Otherwise it's the same. Or to make it easier, we can just move it into this repeat statement, I guess. And we do not need to reset it. Let's run it again. Okay. Let's remove the log that prints the counting. Where's this? Here. That is not helpful right now. And then we end up with those numbers. Okay, this is just after 10 steps we should have this. Okay, let's try 10. It's still 48 milliseconds. Let's see how long it takes for 10. 51, not much longer. That is nice, very nice. But did we get those numbers after 10 rounds? B? No, we did not. It's quite small, to be honest. Almost looks like we are losing track of some counts. we count the characters. We count them for the number of groups. This looks right. Okay, what did we do wrong? After step of it has length of. Can we track the length? Yeah, I guess we can. Because that will be the group count times. So we need no, can we count the length? Yeah, we just need to count the characters, I guess. Fine. This is let's say round. Now we can say round 0 has how many characters? This should be the template length plus the count of the characters. Character count, that will be characters mapped to the count, and then we sum that up. Do not need to know the character. So first round has 7, then it has 13, 25. Yeah, we did something wrong. Let's, no. Did we still use the other template or the actual template? No, we used the actual template. And round is always 0? What the hell? Isn't this the counter for a repeat? Yeah, that should be the index. Why is it always saying? Oh, because we print 0. Let's run this. Okay. What is interesting is it never actually reaches this number. So we start with 4. And then we have 7. That is actually correct. And then the next round we have 7, 4. Next round we have 13. That is also okay. Then we end up with 25. Why is this then wrong at the end? After step 5, it has a length of 97. Let's check step 4 as well, which has 49. Yeah, here it suddenly is not okay. Which is weird. Why does it suddenly become wrong. It's 41 here. So this is the initial one. So this should be 1, 2, 3. Round 3 is suddenly wrong. How's that? How can that happen? There's some kind of new character coming in. Round 4. Can we print the groups? It would be quite hard to actually figure out what's wrong, because they are not in order anymore, which is exactly what we wanted to do here. This looks like we are growing too slow. Yeah, if we... I think I found a problem. If we do the insertion, and we know we do this count times, and then we add those groups, we need to add them count times as well. Because if we find 5 ABs, then we need to add the new groups count times. Let's run this again. Funny that it worked for the first round. See, yes, here's 97 now. So let's comment that out for a sec. Let's go back to our test. If we run this, if we run this 10 times, then we expect the count map to look like, and the count map is a map of characters to longs. So roughly like this. And after B will be 1749. C will be 298. H 161. And N 865. And what's the problem? I'm literally, not seeing the problem. You can't use arrows. Not sure what kind of language I'm writing, but that is not Kotlin. Now everything is nice. Okay, let's remove the print here. And let's run this 10 times. Example 10 times. That passes. Do we have more rounds here? Yeah, we can run this for 40 times though. So let's copy this. This time we want to run it 40 times, and now we see if things are what we expect to be. And if this even completes. So B is happening quite often. Let's see. It does not complain that it's too large for long, which is already great. We only get the numbers for B and H. That is fine. Count map of B. We expect this to be this number, and the count map of H will be this. Let's run this. Yeah, this can be a val now. It's here as well. Okay, exciting. Now let's run a 40. Oh, wow, that was fast. That is super fast. I'm excited. Let's see if you can also get this result. Which means we need the min and max. And I think our helper functions min are for maps with ints. And I will just copy them and say I want the same but with longs. Okay, they have the same signature. Oh yeah, I've been running this into this with Kotlin before. Like, this is only a hint for the compiler. It will not end up in the actual class definition. Like, map does not actually have any types here, accepts everything. So we'll just pick another name for now, I guess. Max long, min long, and this should return a pair, right? Which is the first is the character max char max count, and min long, min count, and min char. And to get this, I think we need to subtract, right? Yeah. So max count minus min count. And we can also compare the chars. We expect the max char to be B and the min char should be H. Run. Wow, I'm still happy how fast this is. So now let's implement part 2. Let's get rid of this crap. What do we want to do? Essentially, we want to do exactly this. And we need a character map and an insertion map. I will just steal this now. The character, like we wrote in 2 insertion map, we could do the same for character map, I guess. Ideally, read file would just return. Yeah, maybe just do this. Fun read file as character map. It's a pair string. And then we want a character map this time. It will look like this. And it will map the values. Oh, this is now a pair. You know what? Let's not do this. Let's do something else. And this is map of a string with strings to character map, which will just do this and return a map of strings to characters. Then let's do this. Okay, we need the character map, which will be our map to character map. Then we create the count map. And let's hope that longs are still long enough for holding this. It was long enough for this example, but that does not mean that it's long enough for the thing here. Max is max char, max count, and min is min char, min count, and then the result is max count minus min count. Let's run part 2 and let's see what happens. We have an assert somewhere that we shouldn't be here. Yeah. Phew. We got a result. Throw this into... Oh no. That is not the right answer. Your answer is too low. We run this 40 times? Yeah, we did. Maybe we are hitting now the problem that we are counting too much, which is larger than long. Is this possible? Let's see. If we open a Scratch file, this is our value. And just making sure our count map, yeah, it is actually using long. Okay, that is good, I guess. This is a long, and this is still a long, yeah. What is the max? Max value. Max, and if we say max minus the value, actually the larger one is this one. So let's put in this. So there's still a lot of room. Let's take a look again. If we did the right and subtract the quantity of the least. You know what? Let's do the following thing. Just to make sure we are still on track, let's run this for 10. Because I'm curious if we still get the right result here. It's B and N and 2000. Yeah, it's not actually doing the right thing anymore. It is doing the wrong thing. Why is this the case? So character map should be right. It is too low. Why is this suddenly too low? Just worked here. Let's run this 40 times, and if we now say, instead of this, say map to character map, and we run this again. Okay, so character map shouldn't have affected it. Yeah, the only thing I could imagine is that the long is still not enough. That we loop. We could try to find the loop. That is something we could do. Let's say we add a character count. Here. Updated is value plus count. This is updated. Let's do this here too. And then let's say if updated is suddenly smaller than the value was before. Oops, we failed. Let's see. We shouldn't run into this here. And let's see if we run into this here. But oh, that was unnecessary. We can still test it for 40, I guess. This is still the same, but it was wrong for 10 already. Let's run part 1 too. Line. I was so happy that it was running fast. Now it was correct with the example, but why is it not correct here anymore? Yeah, there are things missing. Could compare it during the steps. Maybe. Round. And then we need a better divider here to actually be able to read this. And then let's try 5-ish. Round. Count quantities and template. So if we run this, we have 4 rounds with those counts in part 1. And then let's do this in part 2 as well. Print line, round. And this will be our character, count characters. What the hell? This is wrong. This needs to happen here. Okay, the first round is already kind of wrong-ish, but the reason for that is that we one of them includes the template and the other one does not. So what we need is this here. Well, this is the template length. Is the template length helping us? Maybe. Let's go back and for now only log the length. Compare those. So they are already different in the very first round. Why is that? This means we can run this only one time, which is already nice for debugging. And yeah, we get kind of different counts. Let's look at the data. Why is this wrong in round 1, but it wasn't wrong in round 1 for the other one? Something we are doing wrong that only happens here, not in the other case. A form insertion. Say groups. Let's say, see how many groups we look at. In part 1, we look at 19 groups in the first round. And here we should have, let's say, group. Oh, this one might be wrong. Create group count. Let's see. We might have more duplicates here already, and we somehow only, associate them with one. Yeah, that is, I'm pretty sure, is the problem. But let's also make this visible by saying we take the values and sum them up. And then we say we have those many groups. Yeah, we start with not enough groups. This here is definitely wrong, so let's just write it out. So this is a map. Let's not use the fancy thing. Let's use just a regular good old loop. Turn the map. We go over the groups and we say count this group. Now we have the same result. Let's go back, count all the things. Actually, let's get rid of this long ass comment here now. Let's run this again 10 times and this 10 times, and we get a lot of debug output, 2988 and 2988. All right, awesome. Let's do the whole thing again. Let's comment out all our print lines. Keep this one. Do not need this, we do not need this. Lots of print debugging. But yeah, this is much easier to debug, I think, with just printing and comparing values. If we would go step through that with the debugger, we would be absolutely lost. Let's run this. Do we still print anything at all? No. Okay, that is not helpful, obviously. Still want to print this. Now we should get a higher number. We just need to run it 40 times now. And let's pray the long is long. So this was too low. The new value is larger. Awesome, this is the right answer, we found it. Great. I'm very happy that we finally solved this puzzle. I will remove the debugging print statements partially here, and then we'll upload this to GitHub as always. Let me know how you solved the problem. If you have another fancy way of solving part 2 that does not require to build you the string. That was definitely the key here. Again, it's how do you represent and process the data? In this case, either building the string or the stack trace for a recursive solution preserved too much data because it preserved the order of groups, and for calculating the result, the order of groups didn't matter actually. We only needed to keep track of the count, how many groups, and then we could all the same groups, let's say A, B. If you have 100 of them, we can just figure out which new groups come out of A, B, and then times 100, and then we know the counts of the new groups, and so we do not need to process a whole lot of strings, and only the max number of groups, which means in this case will be only this number of groups, which is 100 apparently at max. So we will only keep track of 100 groups and their counts instead of a huge string that we will probably never be able to build in memory. Yeah, thank you for watching. If you like this episode, please leave a thumbs up, and then see you tomorrow. Bye bye.